In this video, we're going to be talking about working with numbers in physics. Specifically, how do we use scientific notation and why is it important? Something I love to say is that physicists are lazy. What I really mean by that, to be honest, is that physicists are efficient. We have to work with numbers that are on the atomic scale, so really small, and on the astronomical scale, so very large. If we were to keep those numbers in their normal formatting, well, we would have so many zeros to deal with and we'd have a lot of issues. So it's just better for our own mental health to put them into scientific notation. Now, I know a lot of people find scientific notation tricky, but it does benefit you in the long run to basically learn it. So, here's what numbers look like as they're changed into scientific notation. One thing I want you to notice is how many zeros we have. So for this number we have 2 zeros and it's 10 to the 2. This number we have 1, 2, 3, 4, 5, 6, 7, 8 zeros, but we want to have just one number to the left of the decimal, so there's 9 things that need to move, and there is a 9 here. So the zero rule works okay, but what you're really looking for is how many numbers are there past the decimal. This works both when you're trying to increase or show that you have a larger number, like these examples here, or show that you have a smaller number, which we'll look at in a second. Now the tricky thing is knowing how to enter this into your calculator. So if you have a scientific calculator, there's a couple things you might see on there. One of the things you might see is something that looks like this. So you might have a 10 to like some number button. Okay? So what you would do is you would enter in whatever your first number was, so like X, and then you'd press that button, and then the next thing that you press would be the exponent for the 10. Okay? Another one that you might see is one that's just 2 EEs. If you have, most of the TIs actually have that. That EE replaces this 10 to the. So this is actually saying the same thing. So what you would do is you put in your first number, you press EE, and then whatever the exponent was. Okay? So that's what you're going to look at in the calculator. Let's go ahead and do some practice problems to get more comfortable with this kind of idea. All right? So let's start with the first one. Okay? So here, what we're going to do is we are going to move some imaginary decimals. So we're going to imagine the decimal is like at this end of the number. We're going to move it over 2 spaces. Okay? So that means that our final number is going to be 2.25 times 10 to the 2. Okay? It's positive 2 because we moved it to the left. So to the left, you're going to have a positive exponent. Okay. Now let's go ahead and do this one. So I'm going to go ahead and move this decimal over so there's just one number to the left of it. So we're going to go 1, 2, but because we moved it to the right, we're going to have a case where it's a negative exponent. Okay? So now we're going to have 2.25 times 10 to the negative 2. So if you move that exponent to the right, that's going to be a negative exponent. Okay. If I were to describe this in layman terms, instead of just like basic rules, I would say that if your number is larger than 10, positive exponent. So if you're making a really big number, which makes sense because then when you multiply it out, you would have a bunch of zeros to the right of your number. If your number is really small, you're going to have a negative exponent. Okay? Now let's go ahead and expand. So what I'm going to do is I'm going to write 3, 2. And then I'm moving this 1, 2, add a 0, and 3. And that's going to give me the number expanded. Okay? Now, for me, whenever I see this negative exponent, my first instinct is to write the numbers with a little bit of space to their left, so that I have space for the zeros that I'm going to add. So here's where the decimal starts, and it's going to go 1, 2, 3. And put the decimal there and a 0, and that's going to give us the number we're going to end up with. Okay, so you'll notice, like I said, positive exponents make us have larger numbers, and negative exponents make us have smaller numbers. If you keep that in mind, it makes scientific notation a lot easier. All right, if you have any questions about this, my email will be in the description box, and have a great day.